Let us study electromagnetic induction with the help of a current-carrying coil. We have taken two coils of copper wire with large number of turns wounded on a non-conducting roll. One of the coils with the largest number of turns is called the primary coil, which is connected to a power supply. And the other coil is only connected to a galvanometer called secondary coil. Insert the plug key and observe galvanometer for deflection. There is a momentary current in the secondary coil. We can see that the galvanometer deflects momentarily. Galvanometer needle jumps to one side and quickly returns to zero. Disconnect the plug key and observe. We can see that the needle of galvanometer deflected again momentarily, but to the opposite side. As we change the supply voltage, there is a momentary deflection in the second coil. We have observed that a potential difference is induced in the secondary coil whenever the electric current through the primary coil is changing. So, we can conclude that the process by which a changing magnetic field in a conductor induces the current in another conductor is called electromagnetic induction.